Hi, welcome to this video demonstration of binary classifier LBFGS logistic regression. In this project, we are going to classify Yelp restaurant review into positive and negative sentiments. So similar to the previous project that you looked at, here we first focus on the structure of the solution. We have a binary classifier LBFGS logistic regression project 1, and we have dependencies program.cs sentiment input data, sentiment prediction output. Since we are using the same Yelp label.csv training file and we are using binary classifier, the project structure doesn't change much. So let's begin. First, we look at the dependencies, and within that we have NuGet, and you can see that I have already included Microsoft.ml, but it's version 1.1. But recently they have updated this package to 1.2. So let's first update the Microsoft.ml package. So right click, and then we go to manage NuGet packages. And we go to browse, and if you have internet connection, then you should be able to get Microsoft.ml latest package, which is here, and you can see that is version 1.2 and we have 1.1, so we need to update this. And when you work on the provided sample solutions for each chapter, you may want to check the latest package at Microsoft.ml and update your packages accordingly. To update, all you have to do is basically click update over here and click OK, and the package should be updated automatically for us. And to ensure that the project has been updated, you open nuget.org and you can see Microsoft.ml now is 1.2. So having done that, let's go back to program.cs. We don't need this right now. So similar to the chapter 1, here we are going to use Yelp label.csv as our training data file. And similar to chapter 1, you need to, chapter 3 on SDCA logistic regression, you need to import Yelp label.csv and make sure that the copy to output directory is always set to copy always. Having done that, let's look at sentiment input data. This is the same file that you have seen as part of chapter 3 SDCA logistic regression. And here under binary classifier LBFGS logistic regression project 1, we have class sentiment input, two properties, public string sentiment and public boolean sentiment, and the same load column 0, load column 1, and these are meant to import the data from the training data file. Most important here is basically making sure that using Microsoft.ml.data has been imported to have the classes and methods that we need to import data for training the machine learning model. Then sentiment prediction output, again we have to import using Microsoft.ml.data. And then we have sentiment prediction output as a subclass of sentiment input data. And we have three properties, public boolean prediction get set, public float probability get set, and public score get set. Having done that, let's look at program.cs. Here we import using system, then we use using system.io. Import ML libraries after installing or updating a Microsoft.ml package. We import Microsoft.ml, Microsoft.ml.data, ML.trainers, and ML.transforms. And then we also import using static Microsoft.ml data operations catalog. We need this to have a reference to the train test data object. So within class program, we specify two paths, one for training data set, a static read-only string training data path, path.combine environment.current directory, Yelp label.csv, and a path to trained ML models. We can save that trained ML model, static read-only string model path, path.combine environment.current directory, model zip. So Next, we define a classify sentiment class, method, within the main method, and then we define that outside of the main method. So here we have public static void classify sentiment. In step 2 we declare ML context, a new ML context, and then step 3 we have iDataView object called training data view using ML context data load from text file. We have sentiment input data, and then we specify training data path that we defined here in step 1. Training data path becomes an argument over here as part of load text file method. Has header is false because we don't have any header in our training data file, and separator character is comma because it's a .csv file. Then in step 4 we split the training data automatically into 80% for training and 20% for evaluation. And so we have train test data which is basically instantiated using ML context.data.train test split method, and we provide training data view and test fraction at point 2 objects as arguments. And we have defined training data view here in step 3. It becomes an argument as part of train test split method. Test fraction point 2, you can specify other test fractions if you want, but the standard practice is 80-20. You can also specify 10% or 30% depending upon your need. So that option is already there. You can change this value. Point 2 means we are going to use 20% of the data for evaluation. Step 5, we create the pipeline object. So we create data preparation pipeline object. ML context.transforms.text.featureize text, and in that method we have output column name features, input column name of sentiment input data.sentiment text. Sentiment text is if you remember, sentiment input data is the input data model that reads from the input training data file yelp label.csv, and so we are referring to that object here so that we get the sentiment text as input to this method, and as output we'll get the features column. Step 6, we create the LBFGS logistic regression trainer. We use the data preparation pipeline object .append method. We instantiated data preparation pipeline in step 5. We are using in step 6. So data preparation pipeline.append method takes ML context.binary classification.trainers.lbfgs logistic regression, and that basically takes argument as label column label and feature column features. Feature column features we defined as part of the output as part of featureize text method. Continuing with step 6, I have it 2 steps broken for step 6. So training ML model using train test data.train test. So we create the train machine learning model here, and we use the LBFGS logistic regression trainer that we defined in part 6 here, and we use the fit method, and we pass train test data.train set, and train test data we created that in step 4. Pass that as part of the fit method, and so we have train test data.train set. That means we are going to use 80% of the training data as train set object to train the machine learning model. Step 7, we go into evaluating the trained machine learning model so we can assess its performance. So we create iDataView predictions for evaluation data view object using model.transform, and we pass train test data.test set. So in this case we are passing test set because we are going to evaluate the trained machine learning model using the 20% of the training data set that has been set aside for testing the trained machine learning model. So we get predictions for evaluation data view. In step 8, we create the prediction assessment matrix. So we have calibrated binary classification matrix object. We use ML context.binary classification.evaluate method and pass the predictions for evaluation data view from step 7 here as an argument, and we specify label column name label. And this gives us the matrix object. In step 9, we display the performance matrix to of the ML model, And here we have binary classification, trainer algorithm, LBFGS, logistic regression. So in terms of assessing the model quality, we have accuracy, matrix accuracy, F1 score, area under ROC curve, area under precision recall curve, log loss reduction, positive precision, positive recall, negative precision, negative recall, and so on. So there are quite a few performance metrics that are part of assessing the trained machine learning model. Some of these terms and concepts have been discussed in chapter 2. So if you would like to review that chapter, it will help you understand some of these metrics we're using to assess the performance. In step 10, we create a sample sentiment text. So these are new text that we are going to use for testing the trained machine learning model, a sentence that we provide as a review. And you can change this sentence to see how your model performs looking at new sentences. So we create the sample sentiment text using sentiment input data class. And then we have in step 11, we create prediction function. So prediction function here is instantiated using ML context.model.create prediction engine. It takes an input data model, sentiment input data, and output data model, sentiment prediction output, and we provide the trained ML model as an argument to the create prediction engine method. Step 12, we use prediction function to predict the sentiment. So prediction result is instantiated using prediction function.predict, and we pass sample sentiment text. We created sample sentiment text here in step 10, and here we pass sample sentiment text as part of this method. In step 13, we write some sentiment result to the output display. So we write console.writeLine prediction sentence. So we want to see what sentence is being predicted. We have the predicted sentiment. So we use converted Boolean method to convert the prediction result or prediction, which will be binary 0 and 1, into either 1 for positive and 0 for negative. And we also want to look at the prediction result or probability. So these are the output of using this sentence and see how the machine learning model is able to predict that sentence. In step 14, we save the trained ML model for further use in our future app development. So using file stream object, we pass the model path that we created at the top of the program here. We created in step 1 model path, and that's the object we are passing here to save the model. So we specify model path, file mode.create, file access.write, and file share.write. And then we use ML context model.save method and pass model training data view.schema and file stream object. And this will save the trained ML model to the specified path. And you can use that trained ML model for developing intelligent Windows applications. So this brings us to a conclusion of our discussion and demonstration of binary classifier LBFGS logistic regression. So having completed the binary classifier LBFGS logistic regression project 1 program, we are now going to run the program to see the output. So let's do that. So we click on run, and we can see the output right here. And this is binary classification trainer algorithm LBFGS logistic regression. First, we have the assessment of the machine learning model quality. And so the different metrics we have is accuracy. F1 score is about 72%. We have area under ROC curve, 83%. Area under precision recall curve, 80%. We have log loss reduction, and we have the confusion metrics, prediction of positive, negative, and we have the recall, and we also have the precision. And then we have a positive precision, positive recall, negative precision, and negative recall, and so down below we also have the specific sentence that we wrote for prediction, which is I love this restaurant. Predicted sentiment is classified as positive, and probability is about 0.65. So it also is able to correctly classify the specific sentence we wrote as part of the new sentence. and it also has saved the model to the specified path for future use for developing intelligent Windows apps. So here is the output of the LBFGS logistic regression, including the performance metrics. Thanks so much for watching.